Hello everyone, welcome to the first chapter of the Huawei HCIP OpenELR course. This section, we will continue to introduce the common service management of OpenELR. In the previous section, we have a basic understanding of MyCircle. In this section, we will install the MyCircle database and practice the related operations.
This page, let's continue to take the school system as an example, using these three models: hierarchical, network, and relational models. In this way, we can review the context of the previous section and make a clear comparison. The hierarchical data model starts from the college root node and set majors and departments under it. There are teachers and classes under the department, and there are students under the class. They can only be one root, one node without parents, and other nodes can only have one superior. In this way, the relationship between teachers and classes, teachers and course cannot be expressed, and this mode does not represent too complex real-world information. The network structure is flexible and can have multiple root nodes, and one node can have multiple upper-level nodes. In this way, majors and department can be established on the basis of the hierarchical model. Teachers, course, and students can build relationships through course selection, representing more complex system, but it is not easy to maintain and query. The relational data models create standardized tables based on real-world concept. Tables are associated by attribute keys, which is clear and easy to query. So let's summary. A relationship is a two-dimensional table, with vertical columns being attribute fields and horizontal rows being tuple records. A primary key is an attribute that uniquely identifies a record. A foreign key is a primary key of another table. A foreign key is associated with another table through a foreign key. The value range of an attribute can be specified by a field. And after understanding the data model, let's look at the characteristics of data. Data stored in the database includes structured data, unstructured data, and semi-structured data. Structured data has a fixed format and limited length. It is usually stored in relational databases, facilitating query and analysis. For example, the driver's license ID, the gender, and the date of birth of the person in the example. Unstructured data has no predefined data model or fixed organization form, including text, image, and video. With the development of cloud computing and the IoT, unstructured data becomes more and more complex and required specific technology and tools, such as natural language processing and image recognition, to parse and understand the unstructured data. Semi-structured data lies between structured and unstructured data. They may not be a fixed data model, but it contains labels or other tags to indicate how the data is organized. For example, XML and JSON files are typical semi-structured data, which represent complex data structures without fixed schemes or tabular structures. In actual data management and analysis, these three data types are often used in a mix. Structured data is easy to manage and query, and is suitable for scenarios where accurate data models are required. Semi-structured data provides flexible data representation methods, which are suitable for the situation where complex data relationships need to be represented. Unstructured data contains rich original information, which is suitable for the situation where information needs to be extracted from a large amount of text and media content. The relational database we are talking about usually stores structured data. The standard language is SQL, Structured Query Language. It is a language designed for managing relational databases. It is mainly used to process structured data. However, it can also be used to process unstructured data through some extensions or tools. SQL is very universal and is the basis for interoperability between different database systems. It includes the following main parts. First one, Data Definition Language, DDL for short, used to define the structure of a database, such as creating and deleting tables. Data Manipulation Language, DML for short, used to perform operations on data in a database, such as inserting, updating, and deleting records. Data Query Language, DQL for short, used to query data in a database. And the final one, Data Control Language, DCL, used to control access to database, such as authorization and revocation. MySQL is the most popular open-source relational DBMS. It was first developed by MySQL AB in Sweden. It was acquired by Sun in 2008 and acquired by Oracle in 2010. Currently, the MySQL database is developed, released, and supported by Oracle. The MySQL database supports the CS architecture and system embedding. For details about the MySQL architecture, let's see the following picture. First, programs developed in different languages can connect to MySQL through connectors. MySQL supports multiple client connectors, including native C API, JDBC, and ODBC. These connectors allow applications to interact with the MySQL server. The MySQL server processes all query requests, manages the database storage engine, and provides various system management and control tools. And inside the MySQL server, it has connection pool that manages and reuses database connections for improved performance. It also includes components such as SQL interface, parse, query optimizer, and so on. The SQL interface receives and processes SQL query requests. The parser parses SQL query statements into internal query plans. The query optimizer optimizes the query plan to improve the query execution efficiency. If the query result is hit in the cache, the query statement can directly query the data in the cache without executing the SQL statement. In addition, MySQL adopts a pluggable storage engine architecture. You can select different storage engines as required for plugin management. The default storage engine is InnoDB, and MyISM is also commonly used. InnoDB supports transactions, that is, a series of database operations that either all succeed or all fail. which is important in applications that need to ensure data consistency. MyISM does not support transactions. Besides this, InnoDB supports row-level logging, which means that only the modified data rows are logged during data modification, such as update and delete, which improves performance in concurrent read and write environments. MyISM supports only table-level logging. InnoDB supports foreign key constraints, but MyISM does not support. MyISM supports full testing indexing, while InnoDB does not. A third-party tool is required to implement full test search. Therefore, the choice of storage engine depends on the specific requirements. If you need advanced database features such as transactions, row-level logging, foreign keys, and so on, then InnoDB is probably a better choice. If you need full test indexing, or if you need more space efficiency in read-only environment, you can choose MyISM. And final part is system files and logs. MyCircle data files, log files, and configuration files are stored in system files. Log files record all MyCircle operations, including query, insert, update, and deletion. These logs are useful for troubleshooting and performance tuning. This is the basic architecture of MyCircle, which is designed to handle both large-scale database applications and specific application requirements.
In this section, we have installed and initialized MyCircle. Learn about circle statements such as DDL, DML, and create a vegetable database and data table. In the next section, we will practice common operations such as query information and user creation authorization based on this database. Thank you for watching.